In this video, we're going to determine if an improper integral converges or diverges by using the comparison test for improper integrals. So here's our integral. We want to determine if the integral from 1 to infinity of cosine squared of x divided by x to the fourth power converges or diverges. So first, let's recall the comparison test for improper integrals. Suppose that function f of x is greater than or equal to function g of x, which is greater than or equal to 0 for all x greater than or equal to some value a, which is usually a positive number. Then here are the two comparison tests that we can use. If the integral from a to infinity of f of x dx converges, then the integral from a to infinity of g of x must also converge. And then the second part of the test, if the g of x integral from a to infinity of g of x diverges, then so does the integral from a to infinity of f of x. So here we have cosine squared of x in the numerator. We know that cosine square of anything is always between 0 and 1. If we now divide everything by x to the fourth, we have the following inequality. Cosine squared of x over x to the fourth is less than or equal to 1 over x to the fourth. And cosine squared is greater than or equal to 0. So if we let g of x be cosine squared of x over x to the fourth function, and f of x be 1 over x to the fourth function, we know that the integral of f of x from 1 to infinity, which is the integral from 1 to infinity of 1 over x to the fourth, we recognize this is what we call a p integral. It's a p integral with p equals to 4. And if a p integral has p greater than 1, it converges. So in this case, p integral has a value of 4, and therefore it converges because it's bigger than 1. And by the first part of the comparison test, if the f integral converges and it's bigger than g, then the g integral must also converge. Therefore, the integral from 1 to infinity of cosine squared of x over x to the fourth converges by the comparison test for improper integrals.